LibreText Introductory Chemistry, Section 1.4, The Scientific Method, How Chemists Think. It could also be called the short epistemology of science. In addition to the text, which begins on page 1.4.1, I will also offer etymology from Etymology Online, ETYMONLINE.com. Etymology is the study of word origin and helps us understand how a word has been used. In the case of the etymology book here, our website that I use, for at least 400 or so years, and how it has been changed over time. Then you will hear the way it is used in the scientific method, or in a science book, or in a science paper, hopefully not losing your understanding of how it's been used before. But if you're here from another subject and you want the word scientific or method, you can say in a chemistry class, scientific means. However, and sometimes this book goes into it as well, and an English class, or let's say a linguistics class, are similar, it may mean something else. And if you're having a discussion between what we will call disciplines, you are a history major studying the history of science, and another person is a pre-medical student studying sciences in order to work on the human body. You may come into conflict with your language as if you're speaking two different languages. You may as well say that language within the sciences is what is called a pidgin or a creole. Uh, Words are taken from English and very likely from Latin and translated to mean something very specific in science. So if you're working on a science paper, you may use words differently than in an English paper. So you can avoid lower grades in written assignments in either subject by knowing which pidgin or which dialect or creole you're using. So the very first word that I've gotten defined from Etymology Online is scientific. Scientific is an adjective, a word that describes. It is from the 1580s to the year 1580 of the Common Era, sometimes said AD or Anno Domini. Concerned with the acquisition of accurate and systematic knowledge of principles by observation and deduction, from French, scientifique, from medieval Latin, scientificus, pertaining to science, from Latin, scientia, knowledge, see the word science, for instance, plus ficus, making or doing, from combining form of facere, to make, to do, from pi or Proto-Indo-European root the, the, to set, put. The Latin word was used originally to translate Greek epistemonikos, making knowledge, in Aristotle's Ethics. And the reader here studies or has studied some Aristotle and appreciates him very much, but I consider myself a Platonist, and therefore I am a Neoplatonist. Learning objectives, just one. Identify the components of the scientific method. The next word for etymology is method. Method is a noun, a person, place, or thing. There may be other categories I'm missing from TEFL. Early 15th century. So the 15th century are the 1400s of the Common Era, or Anno Domini, the year of our Lord. Which Lord? Well, some people will say Caesar. Which Caesar? The calendar that we have today was originally rewritten or re-established based on measurements of the sky with the Antikythera device 175 years prior to it by Gaius Julius Caesar, or Kaiser, who was the tyrant, an actual position of Rome. The kingdom of Rome was subdued by a group of people who wanted to follow the Greek Athenian method of democracy, where a number of prominent individuals with education would meet and agree upon, often by ballot or vote, what everyone should do. They were able to carry that on for some time, but their interest grew from a small city of Rome to something much larger, encompassing quite a lot of the world, today, Europe and Northern Africa and some parts of the Middle East or the Near East. And they needed someone to bring order. So instead of going back to the kingdom of Rome, they went to the religious authority and to the temple of Jupiter. And Jupiter is a planet, uh, and is as a planet, uh, its mass and thus gravity pushes away asteroids that come into the inner sphere beyond the asteroid belt that could hit Earth, for instance, is what we cared about. It also sends asteroids this way, or comets that hit Earth and have hit Earth. And he was called the great lawgiver, Jupiter. And so the priest of Jupiter was Gaius Julius Caesar, and he was brought in as a priest, and as many Catholic priests continue to be. Some take what is called now the vow of John, which is that they have no intimacy, meaning no direct uh, coital contact with the opposite sex, um, and direct coital contact. And so he did not have any direct coital contact with the opposite sex, and so he hadn't committed any of the common Roman crimes uh, consistent with having that relationship. And he was brought in to be tyrant and military authority in Rome. There are many stories about him, but there are many stories about you or your friends or others that may or may not be true that are told to elevate your authority. People think they're elevating. So that's the year of our Lord Caesar. And many people also consider, since uh, the man who has been called Jesus Christ lived during this period and has had the greatest influence over the last 2,000 years, it may continue to. They also say it's the year of our Lord Jesus Christ, because he was alive when the calendar switched over. And he may have been the very reason why it was switched over in the first place. So, method, a noun, early 15th century, regular, systematic treatment of disease. From Latin, methodus, way of teaching or going. From Greek, methodos, So from Latin, methodus, with a U, way of teaching or going. From Greek, methodos, scientific inquiry, method of inquiry, investigation. Go over it again. Originally, pursuit, a following after. From meta, in pursuit or quest of. See meta. Plus hodos, a method, system, a way or manner of doing, saying, etc. Also a traveling journey, literally a path, track, road, a word of uncertain origin. You can see the word exodus. So again, meta, since that's around in use these days, a method, meta, in pursuit or quest of, and so metaphysics, in pursuit or quest of physics, in the method or in the teachings of Aristotle, it is placed after physics. So you learn what physics are, and then you pursue or go on quest for physics. A metaphysics is to go on a quest for. So it is that which comes after physics. What comes after physics? Go find it. Go see what it is. Go use it. And same with this chemistry book. After you learn these things, go find it. Metachemistry, go find it. Go in quest of it. Go see what you can do with it. Experiment with it. Cook something and know what you're up to. Scientists search for answers to questions and solutions to problems by using a procedure called the scientific method. This procedure consists of making observations, formulating hypotheses, and designing experiments, which leads to additional observations, hypotheses, and experiments in repeated cycles. Again, on page 1.4.1, there is figure 1.4.1, which are a basic, a diagram, a flow chart, I believe it's called. And I'm starting with a box called observation, then hypothesis, then experiment, which can lead to a law, or observation, hypothesis, experiment could lead to a theory or a model, which then leads to an experiment again, which you may modify as needed and back to a theory. Some call this the spiral method, uh, thesis, experiment, and return. I'm forgetting a bit of it. But again, here you have theory, experiment, modify as needed, theory, and that's the process again. But you already have your observation and hypothesis. So these are the steps in the scientific method: observation, hypothesis, experiment, law, observation, hypothesis, experiment, theory or model, experiment, modify, and then you have your theory again. Law, again, is when you notice that there is a pattern that is consistent without regard to your theory. Theory is something that you are attempting to find out more. It's the meta chemistry part of it. You want to go in pursuit of it. So you come up with a theory and a theory and a theory. I see this pattern. I wonder if this pattern can do X. I see that this cotton swab is good for taking up some type of moisture. But what if I pick up moisture with it? Can I then put that moisture somewhere? Well, the law is that it picks up moisture. The theory is that you can pick up moisture and put it somewhere else. And then you experiment with that. Well, can I put it on metal? Can I put it on paper? Can I put it on uh, glass, and you'll find out where you can put it. So the first step, pardon, the first step in the scientific method is make observations. Observations can be qualitative or quantitative. Qualitative observations describe properties or occurrences in ways that do not rely on numbers. Examples of qualitative observations include the following. The outside air temperature is cooler during the winter season. Table salt is a crystalline solid. Sulfur crystals are yellow, and dissolving a penny in dilute nitric acid forms a blue solution and a brown gas. Though you should not dissolve pennies, it is illegal. Quantitative, so find something else. It is illegal to destroy currency. Quantitative observations are measurements which by definition consist of both a number and a unit. Examples of quantitative observations include the following. The melting point of crystalline sulfur is 115.21 degrees Celsius, and 35.9 grams of table salt, the chemical name of which is sodium chloride, dissolve in 100 grams of water at 20 degrees Celsius. For the question of the dinosaurs' extinction, the initial observation was quantitative. Iridium concentrations in sediments dating to 600 iridium concentrations in sediments dating to 66 million years ago were 20 to 160 times higher than normal. So step 1, make observations. Step 2, formulate a hypothesis. After deciding to learn more about an observation or a set of observations, scientists generally begin an investigation by forming a hypothesis, a tentative explanation for the observation. So the next word from etymology, etymonline.com, observation, noun, late 14th century, observation, observation, the performance of a religious rite, from Old French observation, which is from around or circa 1200 Anno Domini, or of the Common Era, and directly from Latin observationem, or observationem, a nominative, or the nominative of which is observatio, a watching over, observance, investigation. Noun of action from past participle stem of observare, watch over, note, heed, look to, attend to, guard, regard, comply with. From ob, in front of, before, see, if you're on etymology.com, etymonline.com, ob dash, plus savare, to watch, keep safe, which is from the Proto-Indo-European root ser, which in one definition means to protect. Observation, ser, to protect. sense of act or fact of paying attention is from 1550s, meaning a remark in reference to something observed is recorded from 1590s. Examples of qualitative observations include the following. The outside air temperature is cooler during the winter season. Table salt is a crystalline. Apologize, I'm back in formulating hypothesis. After deciding to learn more about an observation or a set of observations, scientists generally begin an investigation by forming a hypothesis, a tentative explanation for the observations. The hypothesis may not be correct, but it puts the scientist's understanding of the system being studied into a form that can be tested. For example, the observation that we experience alternating periods of light and darkness corresponding to observed moments of the sun, moon, clouds, and shadows is consistent with either one of two hypotheses. A. Earth rotates on its axis every 24 hours, alternately exposing one side to the sun. B. The sun revolves around Earth 24 hours. And there are C, D, E. My C would be um, when sunlight or heat excites helium, photons irradiate and produce light. And there are others. Suitable experiments can be designed to choose between two alternatives. For the disappearance of the dinosaurs, the hypothesis was that the impact of a large extraterrestrial object caused their extinction. Unfortunately, or perhaps fortunately, this hypothesis does not lend itself to direct testing by any obvious experiment, but scientists can collect additional data that either support or refute it. Why the colloquialism? It doesn't seem like one, but it is. Unfortunately, or perhaps fortunately, this is a colloquial usage, a pidgin, if you will, that comes from uh, really political speak. Unfortunately means I wish that we could observe it, or perhaps fortunately, but if we were able to observe it, then we may also become extinct. So the dinosaurs are said to have all died at once, but it is possible that several events occurred where a projectile from space, extraterrestrial, terrestrial is the Earth, extra means beyond the Earth, so a projectile hit the Earth and in spurts or in times uh, killed off those large thunder lizards, as they're known as, some of them with scales, some of them with feathers, and rid the earth of them. There are large extinction level events of mankind that are also theorized to have occurred. And it could be that an asteroid hits the earth and consumes a large part of the dominant species, now humanity, and then we would observe it and know that this is a way that species may become extinct. But that would be quite unfortunate if that were to happen. So it is fortunate that we can't observe it. However, if we ever do observe it, um, you may have a bit of additional observation to add to your hypothesis, and an experiment can occur without you sitting in a laboratory experimenting. I've observed something, I have a hypothesis about it, uh, that if you cause a major impact upon uh, dominoes, they'll fall down. Maybe that would occur also if a major impact was caused among people, for instance. So there are ways to observe it. And if you happen to observe it, and we are so fortunate or so unfortunate to have it occur, still observe it if you're the one observing it and write it down. So, step one, make observations. Step two, formulate a hypothesis. Step three, design and perform experiments. So, formulate from etymology.com is a verb to express in a formula. 1837 from formula plus 8. One out over formulae in 1842. Formulares, 1845. Related, formulated, or formulating. Again, it's from formula, which is a noun, which is from the 1630s. Words used in a ceremony or ritual. Earlier, as a Latin word in English. From Latin, formula, form, draft, contract, regulation. In law, a rule, method, literally small form, diminutive of forma, form, see form, noun, modern sense is colored by Carlyle's use, 1837, of the word in a sense of rule slavishly, followed without understanding, which is from the Oxford English Dictionary, OED, from 1706 as a prescription, a recipe. Mathematical use is from 1796. Chemistry sense is from 1842. In motor racing, class or specification of a car, usually by engine size, is from 1927. Step 3, design and perform experiments. Perform is a verb, again from etymology.com or etymonline.com. It is from around the year 1300, Anno Domini, or Common Era. Performen, carry into effect, fulfill, discharge, carry out what is demanded or required. This is from or via Anglo-French performer, performir, altered by influence of Old French former, form, from Old French parvenir, to do, carry out, finish, accomplish, from par, completely, see per, per dash, per plus fournir, to provide, or see furnish. Church Latin had a compound per formo, to form thoroughly, to form. Church Latin, those two words together, means the Church of Rome, often called the Roman Catholic Church. Church could also mean the common usage upon the earth. Catholic is the name often attributed to a church, and the Church of Rome, headed by a pontiff or pope, currently His Holiness uh, uh, Pope Francis I. That's the formulation, His Holiness Pope Francis I. But Catholic means universal. And universal doesn't mean all, it means that this is the majority, this is the pattern that we've noticed. This is the law. So, Catholic law, this is the pattern that has been noticed over the longest period of recorded history. And it is on offer to examine and even theorize about what it could mean. And the church often is offering theories, which are models by which you can follow the law that they've noticed over time. It could be law written by mankind, or it could be laws, as in chemistry laws. And the Catholic Church has a lot of scientific experiments, and the head of the Catholic Church, His Holiness Pope Francis I, who's the Archduke Jorge Bergoglio of Piedmont in Italy, is a scientist, and I believe he's a chemist. So this has something a lot to do with his work. Step 3, design. So make observations. Step 1. Step 2, formulate a hypothesis. Step 3, design and perform experiments. After a hypothesis has been formed, scientists conduct experiments to test its validity. Experiments are systematic observations or measurements, preferably made under controlled conditions, that is, under conditions in which a single variable changes. Step 4, accept or modify the hypothesis. Etymology of accept. Accept is a verb. In the tradition of Scientology, which is a religion that focuses on how the mind works and changes, especially when words are used, the art that is used to do that is called Dianetics. And within that art, there is a rule, which is that you do not go past a word you do not understand. And that is largely because words like Scientology or Dianetics or sometimes even Catholic in certain families bring up in the center of your chest uh, acid reflux and an emotion that it comes from there. And then if you feel that, that means that you have an understanding. And then ask yourself, what is your understanding? And note it so you can explain to someone when that reflux builds up within you, which is a chemical reaction. I don't like it because it means this. And that will get you a lot further than I don't like it. Or I love it. Why do you love it? Love? Or well, because it means this. For me, I find it useful because I like the concept that you should not go past a word you do not understand, because I'm a writer. And as a writer, I write each word very intentionally so that if you don't understand one of them, I want you to go and find out what that word means. And then after a while, you can just read it and not have to go and look up that word again. So the word here is accept. The context is step 4, accept or modify the hypothesis. Accept is a verb, accept, not accept, which is to remove, but accept, accept, a verb from the late 14th century, to take what is offered, admit and agree to a proposal, etc., etc., or etc means, and there are other things that are related to a proposal that I'm not writing here. To take what is offered, admit and agree to a proposal, etc., from Old French accepter, 14th century, or directly from Latin acceptare, take or receive willingly, frequentative of accepere, receive, get without effort, from add, to, literally the word to, CAD hyphen if you want more for add. So you take add plus capere, to take, and you form ad capere. And this is from the Proto-Indo-European root gap, to grasp. It is related to accepted or accepting. Now again, accept or modify the hypothesis. Modify is a verb from the late 14th century, modifein, modifien, which is to alter, amend, adjust, change the properties, form, or function of. Also, set limits, keep within the bounds of reason, choose a middle course. From Old French modifier from the 14th century, from Latin modificare, to limit, measure off, restrain, from modus, measure, manner, from Proto-Indo-European root med, to take appropriate measures, plus combining form of facere, to make, from Proto-Indo-European root the, dhe, to set or put. Related, modified, modifying. So step 4, accept or modify the hypothesis. A properly designed and executed experiment enables a scientist to determine whether or not the original hypothesis is valid. If the hypothesis is valid, the scientists can proceed to step 5. In other cases, experiments often demonstrate that the hypothesis is incorrect, or that it must be modified and requires further experimentation. One of the most famous hypotheses that is still debated is that, at least the currently accepted, and in many ways, the way we observe things, true, the Earth circumambulates, goes around the sun. The sun of the sky you see, the Earth is circumambulating it. It is going around it. And other planets and objects are going around it. There is still and was a theory that the entire universe circumambulates or spins around the Earth. And there were many arguments about this. And this is a matter of, which isn't defined here, perspective. For utility's sake, if you want to travel beyond the Earth, if you want to understand the motions of bodies as they relate to the most dense object in the solar system, when you know what it is, then that is the sun. And we now understand if there is something extremely dense and bright and productive, you circumambulate around it. You go around and around and around it. Around means a perfect circle, usually, or in its exact form. So I say circumambulate because the Earth moves in an ellipse at various lengths from the sun, and the sun moves in its own pattern back and forth in one of the arms of our galaxy, and that arm carries, it seems, everything in it around the center of our galaxy, which is called Sagittarius A star, which is, at least in part, a supermassive, again, a very dense, a supermassive uh, neutron star, often called a black hole. And black holes are something else you can learn from astronomy. Largely, it's that light. It's difficult to see how light bounces off of it, so we say light doesn't escape it. So that's what we look at. So how is it possible then that the Earth is the center of the universe and that everything revolves around it? Revolves, not circumambulates possibly, but revolves. Well, you would have to know something. So to know that we go around the sun, You have to know that it is there and that it is a system and that there are other things going around it. And this is true. This is observable. This follows the scientific method as it's being taught here. And from the perspective that is most useful for human evolution and development, it is arguably the best way to see things and to pass your classes and go forward in your life, etc. To go work at SpaceX, possibly, and go out to Mars or other places to know where the sun is in relation to the other objects in the solar system is very, very helpful. However, if you learn mathematics, I believe it's trigonometry, where you begin to understand, if you get a chance ever to study Metatron's cube, you'll see all the various ways in which a third dimensional object can be represented on a plane. It is believed, based on other systems, that the universe is a sphere, a three-dimensional object, and that everything we see is on the surface of the sphere. I don't know if we're looking through the sphere to the other side, or if we only can see things that are on the sphere, as if you were, let's say, at the ocean and looking toward the edge. Uh, you can't see the Earth curve, but you can see a reflection from farther away, a fata morgana of the Earth curving farther away. You may not be able to see a ship, actually see it, the ship itself, but you can see a fata morgana, an apparition, which is like a camera, an atlas obscura, or a camera obscura, which allows you to see something reflected that is farther away, up close, because of the reflection in the mist and the sprays. So every point on the surface of a sphere uh, is the center of the sphere. Every point on the surface of a sphere is its center in relation to everything else. So, by the theory of relativity, if you are on the surface of a sphere, meaning the universe is a sphere and you're on the surface of it, you can say that everything is around you because you are the very center of the surface of the sphere. You're not at the origin point of the sphere in the center of the sphere itself, but on the surface of the sphere. Every point is the center. So when people said that the earth is the center of the universe, and that everything revolves around it, they meant that they understood the universe as a sphere, as a giant planet, let's say, the universe. If you're getting ready for, you've already seen Doctor Strange, the multiverse of madness. This kind of gets into the notion of multiverses, multiple universes. But if just taking the one universe as the only one, if it's the surface of a sphere, and if it is, and that is a theory, and there are patterns that show that spheres are the natural way that objects form, very large ones, and that suns produce certain objects that they spit out so that the universe could be a giant sun, and we on the surface of it or somewhere right outside of it. Every point on the surface of a sphere is the center of that sphere. And then if you are on one of those points, let's say the Earth, even if we circle around within our pancreas shaped solar system, the sun, or if we circle around, or if we move kind of like a pinball machine within an arm of our four four-arm galaxy, our point, that dot that is the Earth, that blue dot, as Carl Sagan said, our Earth is the very center of the surface of the sphere. So you can ask your possibly your trigonometry teacher uh, or calculus teacher to what is the theory that every point on the surface of a sphere is the center, and he or she will explain that. If you say that you're trying to find out if the Earth is the center of the universe, they're not allowed to say that, but they might tell you that every point on the surface of a sphere is the center. Is this very helpful to know? It may be one day, but in terms of traveling within our pancreas-shaped solar system, it is less helpful to know than it is that the Earth travels around the sun. So Copernicus refused to think bigger and say, yes, the Earth itself may be traveling in some way, not perfectly circular, but in an ellipse around the sun, and the sun is doing some other traveling. So when you combine the Earth's movement with the sun's movement, then you actually end up with a spiral, and on and on and on into these other shapes of, again, math, similar to a colliding atom inside the CERN Large Hadron Collider. So it gets more complicated. So yes, Copernicus, you're correct, but there are more things to know as well. Well, I just want to know this because I want us to go out into space. And to go out into space, you need to navigate a particular way. And it's just so much easier to navigate based on the sun, which is apparently directly ahead of us. But in reality, because of its weight and gravity, or because of its mass, it is beneath us. The sun is down, and then everything else, the Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, and on, are in higher octaves, some people would say, or higher. We'll get into electron clouds and where electrons are. They are in different places as higher than the sun, which acts as a nucleus. So step four is short, but I just want you to know that these are ancient arguments, and it is not that the church is wrong. The church has many functions. One of them is to administer Mass on Sundays. It's very special. And to kind of keep the story of the Holy Family going. But they also keep some older sciences moving forward. And you may find a part of what is known of the complete knowledge, and you put it forward as true. It is true functionally for purpose, but there is greater truth that if we forget it, it may mean that we get stuck in our pancreas solar system and we don't go beyond it. Okay, so once again, step four, accept or modify the hypothesis. A properly designed or executed experiment enables a scientist to determine whether or not the original hypothesis is valid. If the hypothesis is valid, the scientist can proceed to step five. In other cases, experiments often demonstrate that the hypothesis is incorrect, or that it must be modified and requires further explanation, or it must be modified and requires further experimentation. Step five, development into a law and or theory. So the last of the words I will give the etymology of. Development is a noun, though I think they're thinking of this as a verb. Development as a noun is from 1756. A gradual unfolding, a full working out or disclosure of the details of something. See develop plus ment, meaning the internal process of expanding and growing, is by 1796. Sense of advancement through progressive stages is by 1836. So step five, if step one, make observations. Step two, formulate a hypothesis. Step three, design and perform experiments. Step four, accept or modify the hypothesis. And If it is valid, step 5, the hypothesis is valid. Step 5, development into a law and or theory. More experimental data are then collected and analyzed, at which point a scientist may begin to think that the results are sufficiently reproducible, in essence, dependable, to merit being summarized in a law, a verbal or mathematical description of a phenomenon that allows for general predictions. A law simply states what happens. It does not address the question of why. One example of a law, the law of definite proportions, which was discovered by the French scientist Joseph Proust, who lived from 1754 to 1826. So the law of definite proportions states that a chemical substance always contains the same proportions of elements by mass. Thus, sodium chloride, table salt, always contains the same proportion by mass of sodium to chlorine. In this case, 39.34% sodium and 60.66% chlorine by mass, and sucrose, table sugar, sucrose, table sugar, is always 42.11% carbon, 6.48% hydrogen, and 51.41% oxygen by mass. Whereas a law states only what happens, a theory attempts to explain why nature behaves as it does. Laws are unlikely to change greatly over time unless a major experimental error is discovered. In contrast, a theory, by definition, is incomplete and imperfect, evolving with time to explain new facts as they are discovered. So, humanity is a law with certain patterns that establish us as a unit or group, and humanity is unlikely to change over time without some major regional, let's say, or group experiments uh, where errors are discovered and modified and new patterns are set. But every human being is like a theory, incomplete and imperfect, and always evolving as it learns, and for humanity explains new facts as they are discovered. So as humans evolve from their imperfect and incomplete state, they may offer new patterns which change the laws that are natural to humanity. Because scientists can enter the cycle shown in figure 1.4.1 at any point, so at observation, hypothesis, or experiment, the actual application of the scientific method to different topics can take many different forms. For example, a scientist may start with a hypothesis formed by reading about work done by others in the field, rather than by making direct observations. If you are studying Spanish, for instance, and you normally start with soy, then tú, then I believe after that is eres, then nosotros, vosotros, and uh, I don't remember the last one. But you can enter at tú or nosotros or vosotros as you're learning. Some people may not want to go from soy. Soy in this case being observation. to being hypothesis, and on from there. Um, so you may not want to go in that order. You can enter at some different points, and if you do, then you may end up explaining your conjugation differently. But if you are entering at experiment, don't forget to conjugate all of the word itself. The word, in this case, to be, sad, which is a word that came up earlier. Uh, sad, uh, my Spanish is somewhat delayed. But if you're conjugating a word, then remember that there's the full conjugation table, even the vosotros form, which not everyone uses. Don't forget to conjugate all of it. Don't forget to observe. Don't forget your observation, hypothesis, experiment. And if it's a law or a theory, the re-experiment and the modify is needed, which may be to go through that process again. So it's okay to come in at another point, but don't forget the other ones. You may need to speak to a different person, for instance, or we may need to know that you know them all going forward. So yeah, you can enter at a different point, but don't forget the others. These are ways that you can improve your grades. Example 1.4.1, classify each statement as a law, a theory, an experiment, a hypothesis, an observation. I will tell you now that I will give you the examples and the solution, but I do not have the answers to the Libra textbook for the tests. I looked for them to see if they were available and to offer them. I think either there is an answer key somewhere that you might have to call it Libra text for, say your teacher doing this, or uh, I am learning with you chemistry and going through the process by which you could learn it as a person who I think in 11th grade got a D in this chemistry course, and then maybe got a better grade once I switched it. I'm learning chemistry, so I'm approaching it as an attorney, let's say, as a lawyer would. I have to. I have a case coming up, which involves a patent, and that patent is for a new type of sugar that includes uh, salt with it, just a little bit of salt. And it's called Gatorade. So there's a sucrose sodium chloride drink, and I need to learn a bit about what sucrose is and sodium chloride to be able to argue that my client's product is different than, let's say, Kool-Aid, which is sucrose and maybe some other, and flour or something like that. So this is something different. And so I'm learning with you, learning this, and I'll retain as much as I need to make an argument of that sounds and is chemical, like that sounds like a person who has a general understanding of chemistry and may be able to convince a jury that has a general understanding of chemistry. However, if my understanding as a lawyer or attorney is not enough to convince the jury, then you bring in an expert witness who will then go into detail about the various molecular forms of the sucrose in my client's drink and whether or not they're isotopes or they have other aspects to them as well that make them substantially different from, let's say, Kool-Aid. So this is your Gatorade very different from Kool-Aid? It seems to be in that form. And then we would go back and forth in an argument. And I would then come back and say, but the law says this is how different it needs to be. And yes, we used your methodology, but our product is different. And the law says we can have it as different. Then another expert witness will say, well, people really can't tell the difference and it combines it in this way. So there are generally, I believe that Gatorade and Kool-Aid are different. The aid part may be the overlap, and if they're not owned by the same company, if I don't get something started, then they're probably different patents. But again, I'm learning enough So I can then go back to my law books and say, make an argument so these individuals can sell their products and make their money. And one person doesn't have to sue the other person for uh, patent infringement or some or stealing, or they can write a new patent, and so the patent office for the United States will say, yes, that is something unique. We do like that in our country, our giant company, our corporation. We should have it in addition to this other product, even though they're similar. Or this patent is old now, you can go ahead and make it, but this isn't really different. We're just allowing you to do it for this other reason. So this is why I'm learning it, and I'm going through with you. I'm learning it as you're learning it. I know a bit of chemistry. I've since then studied some more. I went to alchemy and have studied that, and again, I have some philosophical understanding of the soul and the churches and all of that. So I do not intend to take the tests and offer you answers to them. So for teachers using this book that won't be here in this recording, um, there may be an answer key available from the libretext.org and some of the people who've offered it. Or you may be, if you are, the person with who is a chemistry teacher, and you have the bachelor's degree in chemistry or some other degree, or maybe you're a medical student who's teaching for a time. You want to use this book, or you just want to learn it the way someone who wants to make rocket fuel will learn it. Then uh, you would need to take the exam on your own and provide your own answers, or work with a chemistry teacher or someone else who has an expertise, the expert witness, to get the answers. I'm not going to provide them because I don't have them, and I don't claim to be able to derive them. What I do claim to be able to do is to offer uh, maybe even an exhausting, if not exhaustive, analysis of what chemistry is based on the writing here. How do we look at words and where do they come from? And I want you to be able to discuss civilly on these things, or at least to just get rid of some of the arguments I've always heard of that have literally ended in uh, people being very violent toward each other um, over discussing what these things mean and never getting to the point of it. So I will offer a certain level. A chemistry teacher will go further than that, and I imagine if you go about it my way, if I'm a very sweet teacher, you may get a B minus, or a C. But they are possibly they possibly desire you to be able to go on to the STEM, science, technology, engineering, and mathematics, and maybe you can even add the S as a systems approach. My goal is for, let's say, a writer of fiction or a lawyer or a politician to speak intelligently about these matters, to know the places where people like to argue with you, and to so you can go and feel comfortable that you know what chemistry is. And if you're taking a medication or you're taking a vaccine or having some other stance, you'll know a lot more than most people about what you're speaking about. And then the experts are still the experts. You'll have to go to them. So the examples I'll give, and I'll also go through the exercises. But the exams, I don't have answers to, so I'm not going to go through them. Example 1.4.1 on page 1.4.2. Classify each statement as a law, a theory, an experiment, a hypothesis, and observation. So A, ice always floats on liquid water. So for A, this is a general statement of a relationship between the properties of liquid and solid water. So it is a law. B, birds evolved from dinosaurs. B, as a solution, this is a possible explanation for the origin of birds. So it is a hypothesis. C, hot air is less dense than cold air, probably because the components of hot air are moving more rapidly. C. This is a statement that tries to explain the relationship between the temperature and the density of air based on fundamental principles. So it is a theory. You would have to know what air is versus a gas or a plasma to go deeper into that theory. D. When 10 grams of ice were added to 100 milliliters of water at 25 degrees Celsius, the temperature of the water decreased to 15.5 degrees Celsius after the ice was melted. The solution D, the temperature is measured before and after a change is made in a system. So these are observations. E, the ingredients of ivory soap, a unique product that you can buy on the market, not just the color of the soap. The ingredients of ivory soap were analyzed to see whether it really is 99.44% pure as advertised. E, this is an analysis designed to test a hypothesis. In this case, the manufacturer's claim of purity. So it is an experiment. Pure what? Soap. And soap is something unique than, let's say, a body cleanser. So ivory soap might be different than your body cleanser. All right, so exercise 1.4.1. Classify each statement as a law, a theory, an experiment, a hypothesis, a qualitative observation, or a quantitative observation. A. Measured amounts of acid were added to a Rolaids tablet to see whether it really consumes 47 times its weight in excess stomach acid. The answer is A. This is an experiment. B. Heat always flows from hot objects to cooler ones, not in the opposite direction. The answer is this is a law. C. The universe was formed by a massive explosion that propelled matter into a vacuum. The answer is C. This is a theory. The words massive and vacuum may make it more difficult to quantify because it's believed that the universe, this universe, again, the spherical universe, began as a point smaller than the period that you see on this page here. And for some reason, expanded beyond a point where it could sustain itself and exploded into something. Was it the point in the middle of a sphere already and then expanded into it, or was it something else? So this is the theory, but be careful with words like massive or vacuum. Massive, we have an idea of what massive is, and vacuum is also something that people think they have an idea of, but may change with science. So it's not that the universe wasn't formed this way, it's just that there are words in here that may be controversial like massive and vacuum. So again, it is a theory. Michael Jordan Sr. is the greatest pure shooter to ever play professional basketball. This is D. Michael Jordan Sr. is the greatest pure shooter to ever play professional basketball. Answer D. This is a hypothesis. assuming greater means, or greatest means how people judge him versus how many shots he actually made, you can know that this could be an observation as well. So it's a hypothesis because of the word greatest, pure shooter. What does that mean? How do we define greatest pure? However, if basketball statisticians do have a definition of greatest pure, he makes every 7 shots are made every 7 baskets of the 10 he attempted, for instance. This is a possibility. Then it is an observation, not a hypothesis. But again, because we don't know what greatest and pure mean, our greatest pure shooter in this case, the book has made it a hypothesis. Or because this book is from California, there's a bias. E. Limestone is relatively insoluble in water, but dissolves readily in dilute acid with the evolution of a gas. Limestone is relatively insoluble in water, but dissolves readily in dilute acid with the evolution of a gas. So E, this is an observation. I would want to know what diluted the acid. If water diluted the acid, then the observation needs a bit more explanation. Okay, a summary. The scientific method is a method of investigation involving experimentation and observation to acquire new knowledge, solve problems, and answer questions. The key steps in the scientific method include the following. Step 1, make observations. Step 2, formulate a hypothesis. Step 3, test the hypothesis through experimentation. Step 4, accept or modify the hypothesis. Step 5, develop into a law and or a theory. For this section 1.4.1 or 1.4, the contributions are the contributions and attributions. This page was constructed from content via the following contributors and edited topically or extensively by the LibreText development team to meet platform style, presentation, and quality. Wikipedia, which takes donations. Wikipedia, wikipedia.com. Why do some teachers say you can't use Wikipedia as a source? This goes to a rule about encyclopedias, not necessarily the quality of Wikipedia, that an encyclopedia is usually an anthology, and each encyclopedia entry in, let's say, the Encyclopedia Britannica was written by a single author. So that single author you can reference and say, Encyclopedia Britannica, 1976. The article is The Sun, and that article was written by, uh, Sir Walter Scott, for instance. And so you could cite Encyclopedia Britannica's article in The Sun because you have a single source, an author who you can name. Wikipedia uses a team, and certain certified people can go in and modify it. And they don't always have, often you'll find a tremendous number of further citations and places to look, but rarely, unless you know how, do you find the name of a single author for that entry. And so, because of that, it's not that the information is incorrect or unreliable. It's actually really reliable for general knowledge. If you want to know something and want to go and then do more research on it, it's a great place to begin, or even stop there to know what it is. But you can't cite it because of citation rules, that it isn't clear who wrote it And so you don't know if that person had a bias or not, if that person was a PhD or or an expert in that field, etc. You can't. If I, why do I want your citation? I want to know who wrote it, and so I can look and say, okay, you got this information from this source, and it's from Encyclopedia 1972, Encyclopedia Britannica 1972, by this author. Well, we've learned a bit more about the sun since then, but this author was the expert in everything related to our sun. And so that's wonderful that you have this here. Next time, maybe look at Wikipedia and see the sun and who else has been writing about the sun, and then go to their works and get more information. But if you have a paper about the sun, what a Wikipedia article is a paper. It's like the paper you would write if you were trying to write, or if you were assigned a paper about a topic. This is that paper. And so quoting Wikipedia is actually quoting someone else's paper, and actually is a team of people's paper. And the goal of writing a paper is that you go out and do the research on it, including including Google. I went to these 5 Google sites managed by these people who wrote them, and they said this. Or this is a database that I took it from. And so that's the reason why that is the case. So Wikipedia is one of the sources and contributors here. Again, Wikipedia, wikipedia.com, takes donations. I apologize, Marissa Alviar Agnew from Sacramento City College, or Sacramento. Henry Agnew from UC Davis. So just as you should try to add the accent to Spanish or French or Arabic names, if you know what it is, or you make an attempt, you should also add the accent to English names. Henry Agnew, and there may be other ways to pronounce it. So it is as appropriate to, and I do this in some of my other readings on YouTube, I will switch from what is almost a French Canadian, Quebecois French, uh, and some attempt at a continental French, to back to an American English, or I would argue it's yet again maybe an Ontario uh, English, somewhere closer to the United Kingdom, or a Newfoundland English. So I will switch back and forth in my accents. Um, to make sure that I'm pronouncing the English, because there are some people listening who want to pronounce English differently or better, and that I am attempting to pronounce the Spanish and the French, owning to my own heritage in those cultures, and that some of this work comes from that, or Latin. I really do try to do there. And if there are Arabic names or things like that, I've learned Arabic, and there are different dialects of Arabic. I do make an attempt to switch back. So if you speak with an accent, it is appropriate to pronounce English names the way that the English, or at least the Americans or Canadians, would pronounce them, just as we often ask uh, those with an English accent to pronounce Spanish or French or Arabic names according to the convention. That is the end of 1.4.